Good afternoon, everybody. So I think it's pretty late already, so I try to keep things fairly high level in this talk. Where's the? Okay, if I can start the talk. Nice. Okay. So I work for a company, or okay. I'm the co-founder of a company called Ethcore. We develop blockchain technology. We're based out of London and Berlin. And I want to give you like a brief overview, like what's been going on in the space so far, where things are heading, what happened in the last few weeks to the Ethereum project, and so on and so forth. Maybe just for me to get a feeling, like who of you feels comfortable explaining what Bitcoin does? Okay. Who of you, do all of you know Bitcoin? Who of you knows Bitcoin? Like, okay, pretty much everybody. Who of you owns Bitcoin? Okay, fair amount. Who of you has some Ether? Okay. Who of you has heard of Ethereum before? Okay, cool. So that's nice. Great. So So basically, this whole thing started about like in 2008 with Satoshi Nakamoto publishing a white paper called a peer-to-peer electronic cash system that we now know all as Bitcoin. So it's kind of, people also call it funny internet money, where you can directly send cash back and forth in a peer-to-peer manner. So initially it didn't have much uptake, but then kind of over time people realized that there's potentially something bigger behind it. And so further onwards, people, by the way, like if I say something that you don't know, haven't heard of any terms, like I might use some terms that are quite like typical for the blockchain ecosystem, just interrupt me, or like any other questions in between, I'm happy to answer. In any case, like people understood that there was something bigger behind this technology that could be quite useful for the way how we interact and transact on the internet. And so people quite quickly started then abstracting the whole notion of a blockchain. So there were projects like Mastercoin and Colored Coin that tried to use this peer-to-peer network in kind of different ways for domain registration and other things. Kind of either building directly on the Bitcoin blockchain or slightly altering the protocol in order to make it useful for other systems. But then over time, people realized that potentially things could be done in a slightly different way, and this was when the Ethereum project got started. So Ethereum basically was the idea of, instead of just slightly altering the scripting language that you have in Bitcoin, you put a virtual machine on top of the blockchain, and so what you get is basically what we now call a global decentral computer, kind of a serverless infrastructure that can be used by everybody as a single environment for deploying programs that can be used by everyone in an open fashion and in a secure way. So it's kind of, one could also think of like APIs even like done a big step further. So because you have this single shared environment where programmers can freely interact with each other, talk to each other, and you can be sure the program as you deployed it will be executed in the way you deployed it, and you know what you get when you call other functions in other programs. But it's not just interesting from a technological perspective, it's actually way more interesting, I think, from a social and human perspective, in that by not having this central architecture with a server in the middle, you all of a sudden can deploy services that don't require this middleman keeping track of things. So, because so far the internet was basically good to distribute information, but then as soon as you wanted to transact something of value, you needed to resort to a third party, be it like a big bank, or be it Uber, or any other system that keeps track of who owns what, who transacts with who, and that we have to go through in order to implement a service. So I don't want to go too much into detail about like financial applications because it's actually more interesting, I think, to talk about different applications outside of the financial realm, and also much more educational because it makes you think of how you could use this system in other settings beyond finance. So one of the projects that people are currently working on is a system called Firecoin. It's a decentralized cloud storage, basically, where you can host and share data. And through this virtual machine, you can implement the whole incentivization mechanism for people to host that data, and also for people to trustlessly check whether or not the data that you assume is actually held by another peer in the network is actually still there. So another system which I just came across, this is actually quite interesting in probably how we're going to see systems like Bitcoin and blockchain being used in the very near future. It's called GetMoney, and what it allows you is to contribute micro tasks, basically in a GitHub-like project, and then as soon as you commit your work to GitHub, you automatically get paid in Bitcoin. So it also shows. This project also shows like what kind of infrastructure will be needed in order to make such decentralized systems work. One thing that here comes in, and the way how GitHub acts here, is as a so-called oracle that feeds outside information into the blockchain. So in the previous example with the Firecoin, we also had a similar data source, so people have to do a cryptographic proof that they own a certain bit of a file, which then goes into the blockchain. And in this case, it's data that can be directly fed from GitHub, for example. Another interesting project that I've been also involved with is a system called Provenance. Here, in this case, the actual asset that's being transferred or that people are interested in are certificates that prove authenticity of a physical good. So think of your fair trade FSC a certificate that shows a certain way of manufacturing for a product. Right now, all these systems are very much paper-based. I mean, not only are they not digital, but they are also even paper-based, and it's really hard to verify that the product you actually buy is organic whatsoever. With such a system managed through a blockchain that overcomes all these trust barriers that you find in a supply chain, in a shop, when you scan a tag, you could actually see that the certificate is authentic in the sense that it hadn't been double spent, because this is what the blockchain originally solved as a problem. So not being able to double spend a digital asset on the internet. So right here, you also have, again, like a data source that comes into the blockchain from the outside, namely through scanning this tag, this information is being fed into it to verify that this tag is actually authentic. A third system, a third really interesting startup is called GripSingularity. They deal with decentralization of energy markets. So you could think of your peer-to-peer trading system that some people might have read about, but even more broadly, also on a higher level where utilities actually consolidate who bought energy on which day from whom could be run onto such a system. And especially in countries where there's less infrastructure for managing such data exchanges in a trustful manner, this could be a really good approach to speed up very liberal energy markets and thus help economies to develop. Just as a side remark, what's quite interesting about all these blockchain applications is, in recent years, what we've seen is how monetization basically moved further and further up the stack. So eventually with like these aggregators, Airbnb, Uber, monetizing all the data that's been put into the platform by other people. But what blockchain could allow through the issuance of tokens that are directly tied to certain protocols, they could help maintain that or could lead to a monetization further down the stack on a shared platform that goes across also different industries, and thus quite dramatically change the way how businesses work, actually. One interesting example that goes into that direction was some project called the DAO. Has anybody heard of the DAO over the summer? Okay, a few people. So DAO is shorthand for Decentralized Autonomous Organization. What happened in this case was basically people used this shared common global computer to deploy a program that models an investment fund. People could decentrally buy in without your Kickstarter behind, but just buy a token that represents their ownership in the or their stake in the DAO. Then the DAO was supposed to so it also came with voting mechanisms. So the DAO was supposed to invest in the future. Raised about 160 million US dollars over the summer, quite a bit. But then unfortunately this happened. So this program had a little bug, and it allowed an attacker to withdraw the money from the DAO contract. So basically, I think it was like about 2.5 months ago. It was a Friday morning when we realized, and this is all public, can publicly be observed on the internet, when we realized that the DAO is getting drained because of a bug. And what then started was a big debate around in how far what is called also a smart contract, this program on the blockchain that basically mimics a digital agreement between parties, and how far this code actually should be law, and whether the attacker, by what he did, just didn't actually exploit the program, but just behaved according to the rules that were laid out in the program. Basically, some people argued the DAO is the code in the DAO is law. And so there was a bug in there, or some people just perceived it as a bug, while the attacker argued, or people around the attacker potentially argued, that actually it's fine because, yeah, this is how the code works, and it was advertised. In any case, what we then saw was what's called a hard fork of the protocol, which was quite contentious because of these arguments around, is a smart contract on a blockchain now the actual agreement, or how does that work with the law in the real world? So there was this hard fork, which was pretty controversial, and many people also argued that this is quite a big setback for the blockchain development. I would argue it actually made the system harder. So in some ways, we are really still in the early days. I mean, many people, there's a lot of buzz around blockchains, and many people, I think, overestimate a bit where we are at the moment with these systems. It's really early days. Like Ethereum is just 2 years old, or like the actual operational Ethereum is 1 year old. And you'd expect that there could be bugs, that there could be issues which need to be fixed. I think it's actually quite remarkable that through this hard fork, what could be made was to fix this bug and basically give the money that people had invested into the DAO back to these investors. Which, I mean, think of all the cybersecurity issues that are ongoing in banks. Like, once the money is gone, I've rarely heard of any cyber attack where like money could be restored, like where the status quo could be restored and like people got their money back actually. In recent weeks, we had. Does anybody know which country this is? Which Venezuela. So, recently, we had a little bit of a similar issue to Venezuela, in that that certain operations were underpriced in terms of what they actually cost. So, as I said, there's this virtual machine on the blockchain, which where you can execute opcodes, and certain opcodes were wrongly priced according to the actual cost they cause, which was was basically just a mistake in the protocol. We were quite lucky that most of the implementations were very robust in that sense. So we ourselves did a new implementation of the protocol in our company Ethcore in Rust, which was quite a useful thing. So they could deal with that overprice, with this underpricing of that cost. Nonetheless, does anybody know what this is? This is the landing computer of the Apollo 11. The reason why I'm talking, or why I put this photo here, is that In the development of the Ethereum system, we followed certain approaches that actually proved quite useful. In that, in contrast to the Bitcoin system, there first was a formal specification, and then independently, multiple implementations were developed. So you find this usually in aerospace, for example, where you have at least 3 different implementations that first need to show that they, under all tests, come to the same result before systems are allowed to go operational. And we did the same thing. So there are, which is quite a big effort, but which proved to basically save the network, in that there are different implementations completely independently built just based on the formal specification and nothing else, and that come to consensus in all cases. In any case, there will be another hard fork, so the protocol must be fixed, similar to the DAO, and I hope that the media won't go crazy again, because in this case it's just a fix to the protocol, to an issue that was in the protocol itself. So yeah, I hope this will again lead to making the system much stronger. So maybe just a brief outlook in terms of where we are now and what's on the horizon for all these systems. So the biggest, one of the biggest issues that's being discussed at the moment for blockchains is the scalability. So Bitcoin, like the number of transactions that you can do per second for the system. Same problems exist for the Ethereum blockchain, and it's one of the issues we are working on as a company to make the system actually much more useful in the wild. Otherwise, we are also working on infrastructure that makes it possible to integrate the blockchain into existing systems, like a plugin for a browser, and will hopefully lead to much more secure infrastructure overall when we interact on the web, by introducing secure signing mechanisms, having really high security around wallets, people being having much more agency over their data and how they transact on the internet. For this, if you know anyone, we are hiring and that's the only advertisement I really want to make. We are hiring a designer who would be excited to work with us on this stuff. Yeah, I mean, I hope I could give you like a little bit of an overview, like how we as a company see things going. I mean, I guess I could go into more details how the system works, but I'm not sure really how useful this is. I'd rather be interested in discussing with you. Maybe you have like ideas how you'd use this stuff, or maybe you have some experience of building a proof of concept in your own company. Yeah, so I'd like to hear from you. I think I was way too quick, I guess. Yeah. Yeah. So there was not. So I'll just repeat the question. It was about how it worked, or what kind of methods we use for the formal specification. So it's not really like a particular method that we use, but it's mainly formalizing the protocol as mathematically as possible. So you can actually check and verify just with paper-based, basically the working of the protocol. It was in fact developed in parallel with the first implementation. So it's not that it was purely paper-based and then there was the first implementation. That was hand in hand, but different implementations were developed in parallel according to this specification. So that was, I think, the important point, that nobody ever looked into the other code base. So it was not like as for Bitcoin, where now you have re-implementations of the Bitcoin protocol, which actually re-implement certain bugs that were present in the first implementation. Yeah. Any further questions? Anything? Yeah.
Do you think a hard fork is going to be feasible when this is getting more popular? Then you've got so much transactions going on that people are just going to find it practical.
Right. So it was about whether or not a hard fork will be feasible in the long term under certain circumstances. I mean, so the hard fork, basically how this worked for the DAO was people tried to get a sense of whether there's enough support in the network before the hard fork in order to make sure that there won't be any technical issues once the protocol gets changed and the client's updated. Bigger the system grows, or the bigger the network grows, the more difficult it will be to come to consensus. I mean, it will depend on like which kind of things you want to change with a hard fork. For the next hard fork, I'm pretty confident it will be really easy because it's just a technical issue that at the moment exposes the system to a DOSing attack. So there's no sense in kind of sticking to the old protocol because it makes the system basically useless in the long run. There are ideas of actually implementing kind of the voting mechanism for upgrades into the protocol itself. So this could all be abstracted and automated in the governance. But yeah, I think that's a really important thing to consider, like overall how these distributed systems that have so many different stakeholders can be governed as a whole, because we are seeing this now in Bitcoin at the moment. There are many discussions going on. What kind of fixes people want. Miners prefer this because they can get more revenue by a certain alteration of the protocol. Other stakeholders have other ideas. And so I guess some automation that gives stakeholders an opportunity for systematically engaging is a really good idea. So that's something on the horizon for Ethereum potentially. Yeah. Yeah. Say again?
Do you have any more information about whether people got the $160 million back over the summer? And can that provide any guarantees for future investment?
So basically, what happened was this. The question was whether or not we have information on whether people got the money back and whether this money can be used in the future. That was the.
Or the process works whereby people got the money back.
Yeah. Okay, so first of all, the way how the hard fork worked was basically this smart contract that modeled, or this program that modeled this DAO was replaced by a different contract where according to how much you bought in or according to how many tokens you held, you could claim like the ether back that you invested in the first place. I think, as far as I know, that that program is, or that contract is now more or less drained. So most people just reclaimed it by doing a transaction and got the money back. In terms of the confidence, I think it has changed things quite a bit. So currently there's like a little parody which came out just a couple of days ago. It's called the ICO.info, the ICO something. So people just making fun a bit about all this hype that's been going on. I mean, there are like loads of projects that try to raise money through these crowd sales, and some of them have surprisingly little material online in the first place when they try to raise money. I think people are still quite excited about this opportunity for the blockchain being this out-of-the-box organizational tool for getting people to collaborate together. I think that still holds, that people are really excited about it, but people are a bit more skeptical about marketing around these projects that do try to raise crowdfunding. But I think that's the same problem for kind of classical crowd sales as well, where people could just not deliver what they wanted to deliver. I mean, that said, there is some skepticism around in how far we need better methods to check bugs in codes. Which actually now caught the attention by people working on formal methods, formal proofing. So I guess we're going to see a lot of PhDs coming out on that topic, which is pretty cool to see, because before they were basically limited to aerospace and nuclear power plants for checking what they do academically. And yeah, I guess we're going to see this a lot. We have ideas on around like that there is a way when people try to engage with such a smart contract, a way for checking that, for example, you could be sure that the number of tokens that's represented is actually an invariant or whatever, and similar things. So I guess in the future we're going to see like an entire ecosystem, kind of maybe foundations. The Electronic Frontier Foundation has people like checking such contracts, and then you can be sure they're certified. So you have kind of a plug and play big library of contracts that people actually trust. and where they can like reuse certain elements and stuff. I think that's what we're going to see in the long run, kind of these microservice contracts that you can mash together and build a new system, and which will make it much easier for people also to build their own thing without going through this whole mechanism again. Is that again? I didn't.
I heard you say just now that basically with this sort of stuff that it's basically some kind of virtual machine sitting on top of whatever that you're trying to protect or capture. I don't know what's the right term. So this is new. This is my first time to do this. So now if you are a novice like me and I wanted to incorporate it into my system. The way to do it is to build different virtual machines on top of different things you want to protect?
Oh, no. I mean, there's like this. This is like, so the question was like whether or not when you want to use such a system, you need to build a virtual machine yourself or put it yourself on top. Like, I mean, the idea behind Ethereum was like to build this general purpose blockchain that people can really easily use in their systems. So there's a JavaScript API as well for people, so that actually also just normal web developers can easily build like a decentral application that has, instead of a centralized database, just this blockchain computer also in the backend, or this serverless infrastructure in the backend. So it wouldn't, like, in the long run, once we have all the tooling around it, it wouldn't require you to like do really highly sophisticated development before you can use that system. It's very much like a common infrastructure for everybody to easily use. That's at least the vision. Yeah.
If it is common and easy for people to use, is it not then easy for the hacker to hack it in?
Well, I mean, yes and no. Like, why do you think just because it's for everybody to use, it should be easy for the hacker?
Because a lot of the problems with hacking quite often happens when something is like really accessible and easy to use, and this is where people figure out a way to hack it in, and then you get, that's where a lot of hacking happens. Like, for example, so many cases even if you talk about things that is outside the Bitcoins at the moment, maybe things like blockchains and all that is secure because a lot of people still doesn't know about it. Whereas if you then make it accessible and what not for people to know about it, sooner or later there will be nutters who will come in and hack it because they know the way around it. Then they will, because in ordinary system there have been so many cases of of people having known the system, they hack it in, and they, you got like known company, even my own service provider, like TalkTalk last year was hacking, and then there's so many you can think of, and you can look at all kind of things. And then a couple of years ago, there were like GoDaddy's, clients was hacking. People think that it's because GoDaddy is so cheap and it's easy to whatever. But then the companies who are hacking, they actually have their own server from GoDaddy. So you see what I mean?
I think one important thing here is that this is an open infrastructure for everybody to use. I mean, I think in many cases, if you try to be cheap, then you often have to compromise, but then you run and protect your own systems, right? I mean, while this is like a native protocol that can be also improved by everyone. Also, most of all the clients are open source software, so everybody can look into the source code and check things, can improve things. I mean, just because I don't really get, like, just because it's open, and I mean, there's of course like a design challenge when it comes to user interfaces, and like people maybe accidentally providing their private keys to someone which they didn't want to. But like for the core system, I see a big strength in this being like a single infrastructure. I mean, if we did get like funding right for for SSH, for example. I mean, for other crypto libraries as well. I mean, we could probably pretty easily improve such libraries as well, which are used by a lot of people. I don't really see why being open and easily usable should directly lead to difficulties, unless you mean a particular service that's cheap and therefore compromises on security because they don't have the money.
Like that. Like for example, I forgot. There's a company, for example, who actually actually, when it comes to GitHub, they actually provide something similar to GitHub, but the client that come to them actually use them because they want to be kept separate from GitHub, so that people don't abuse the system, the company staff and whatnot. So, because this other company. They actually run a whole lot of other stuff. Something similar to GitHub is what they provide for their clients as separate services. And they say to us that the client actually come to buy this rather than what you can get at GitHub because they're kept separate, which means that they are more secure and everything like that. So that's why they.
Okay, it's hard to comment on that particular case.
So I imagine that with this thing might have to do something similar in order to protect your company's security.
Yeah.
Yeah.
What is the cost of running this, and how does it compare to, let's say, traditional methods?
I mean, so there are different estimates on like how much it costs. So costs come basically into the system from the miners who maintain the system. I think it's less useful to look at the current cost because there's still like loads of technical development going on. So people working on getting from proof of work to proof of stake, which will probably dramatically decrease the cost. I mean, at the moment when we talk about transaction, like it's like micro cents, like that's kind of the rough ballpark. But I expect this to come down quite a bit over the next years as these systems mature and become more efficient in terms of the processing power. Yeah. Yeah.
Examples of services that are currently running on Ethereum?
So directly services that are run mostly are at the moment exchanges. That's something which is operational. There's another platform. I mean, I spoke about these startups, right? I mean, they are developing proof of concept or early products that run on top of Ethereum. There are a couple of projects. One is there are two bigger prediction market projects who want to go live pretty soon, I think, which is an interesting concept as well. There's an overview. I can provide you with a link. I mean, most of them are still in an early stage, so there are not that many, apart from the exchanges, who run a business on a day-to-day basis already on the Ethereum blockchain. Yeah. Yeah.
You mentioned that there's some sort of network.
Mm-hmm. That's for both systems. Yeah. So Ethereum Classic, just for the others, Ethereum Classic is the system that, like that's the non-forked system. So which still has the buggy DAO, so to speak, in the on the blockchain. So it's a different way how history could have been continued. So it's the same problem. It's just the same issue. I'm not sure. I mean, there's currently like mining power anyhow, as far as I heard, leaving from Ethereum Classic. I don't know what's going to happen. I think they're relatively mature in terms, immature in terms of their governance. So I don't even know who drive that that hard fork. Peter, do you know maybe anything about ETC hard fork? Yeah. Yeah. I mean, it wouldn't be too difficult to transfer what's been developed for the Ethereum system to the Ethereum Classic system, but yeah, I'm not aware of anybody who's implementing it. Yeah. Yeah. It's two blockchains now, yeah, which were just the same like until this first hard fork happened, and then so what we actually thought back then, or what the theoretical thinking was, If there was ever a contentious hard fork, what would happen is, like maybe for a couple of days, there are like 2 chains, there's some uncertainty around which one is the winning one, which one is the one that's not going ahead. But what effectively happened in this case was that there were enough miners who stayed on this Ethereum Classic, so on the unforked chain. And so currently we have two Ethereums, like one is supported by like a really big network of miners and then the smaller one. And it was also interesting in terms of seeing how like what's called the market capitalization got spread. I mean, of course, uncertainty always causes crisis to crash, which happened for Ethereum as well. But then, yeah, so at the moment, Ether Classic is like traded at $1, I think. Ether itself is traded at $11 or $12. So, but yeah, there was like a big bit of hype then after a few days around Ethereum Classic, which led to a price spike of $3, and now it's down to 1 again. So I expect we're going to see it probably slowly dying, like similar to other altcoins that we've seen for Bitcoin. But yeah, I don't know. I mean, yeah.
Okay, we have a couple of questions coming in on the app. So
yeah.
you mentioned that the blockchain can verify ownership of an asset, taking an SSL certificate, for example. How does the system firstly declare ownership of the certificate, and how does one verify the ownership?
So, I mean, initially so if you have something that's existing in the real world or outside of the blockchain, you always need some process for getting it into the blockchain. So as I said, like similar let's not talk about this SSL specific question maybe, but about other assets that you want to kind of shadow on the blockchain. So you need some mechanism to get like this ID of something in the first place on the chain. That's probably like some company who takes care of that. That is kind of trusted and has some processes for doing this in a way. But then the verification can be done by everybody independently. So maybe you need a QR code that you scan in terms of these physical assets, and then you can verify the identity of that product.
Yeah, and the last question we have at the moment, that is, what time horizon do you envisage before it becomes commonplace payment?
That's an interesting question. I mean, 6 months ago, I would have said probably like in half a year. I don't know. But now, I mean, mainly what we'll need is a lot of tooling around these systems to make it much more easy for people to use. And then similarly, the corresponding infrastructure for users, that what we are basically also working on in the company. I think once we have that and like it becomes fairly easy to develop applications on top, it can be quite quickly. I mean, we've seen adoption of other applications that you have on mobile fairly quickly. So that's, I think, the more relevant point.
Yep. Another one coming in. Do you see Ethereum applications replacing Bitcoin in the future?
It depends on. I think there are some use cases for Bitcoin where Bitcoin excel, especially with the Lightning network coming on. So like a network or like an add-on to the Bitcoin blockchain that allows micropayments in a very efficient manner. I think we're going to see like loads of different chains that then interact with each other and for particular purposes. And there's kind of a master chain that then makes it possible for all these chains to talk to each other, which is at the moment not possible.
Now people start to use the app here, so is there a way to host web pages on the Ethereum network to make them more resilient to attacks or censorship?
Well, there are ways. I mean, like you can, as I said, like there's tooling for web developers to basically use JavaScript to develop an application that leverages the Ethereum blockchain. What you still need, I mean, the Ethereum blockchain is fairly limited in terms of storage. So you'd only want to put the logic on the chain that actually needs to be agreed on by everybody, like just the very essential logic, and then anything else, any like additional information, photos or whatever, for which you might need to check kind of some authenticity through like putting the hash of a photo on the blockchain, but not the photo itself, because there's no reason why you'd put a photo in the first place on the blockchain itself. So you'd host that maybe either on a centralized server or like on something like the Filecoin system that I mentioned earlier, which is like a further development of things like BitTorrent to host stuff in a decentralized way. But then, yeah.
And what applications do you think will speed up Ethereum adoption?
I think like applications like this Provenance application, for example, where it's very unnoticed that there is actually a blockchain behind. I mean, who cares like which database in the end is behind this stuff? So as long as it gives you an additional value or an additional service that you don't have at the moment, which in this case is having a single source of truth for where stuff comes from in a supply chain. I mean, I'm also waiting still for somebody to implement actually a decentralized Uber. There was like some buzz going on around a startup who wanted to do this. So decentralized Uber basically consisting of a marketplace for rides that you can then, for which you can do the processing of the business logic on the blockchain, and then, for example, also insurance could be handled through the blockchain, like microinsurance just for the particular ride. That's something I'd like to see. I mean, basically, I mean, the thing is, we don't know what these systems are going to do, so the best thing the best thing we can do, I think, is to just take it, experiment, and play with it, and see where we get.
And what are your thoughts on Ethereum and Microsoft Azure?
Well, I mean, I think it's a good thing that there is so Microsoft and Microsoft Azure and the blockchain. I think that refers to certain blockchain implementations that are now available on Azure for people to be able to play with in the corporate sphere. I think that's a good thing. So it makes it accessible because it's really difficult, as far as I know, to often get like kind of verified software running in a corporate environment. So that's a good thing. At the same time, what I fear at the moment is there's lots of discussions going on about private chains and what they can bring to enterprise. So I think there is some value of private chains, so a blockchain that's just limited to certain users. But then the big innovation around blockchain is this open network that can be used globally on the web, and that's free for everybody to access, open to access.
Okay, thank you very much, Jutta. I think we are slowly running out of time, so thank you.